Hello everyone, I'm Akash Joshi. I'm the operations research guru, and today we're going to be talking about the idea behind the simplex method. There are plenty of videos on YouTube explaining the simplex method, so if you want to go watch one of those on how to actually perform the simplex method, please do. I will likely also be uploading a video on how to do the simplex method, but this is just simply explaining the methods and processes and the thinking behind the simplex method. So the simplex method was invented in 1947, and it was invented by an operations research analyst, and he was the pioneer of operations research. So yeah, a way to solve any linear program by hand. That is what the simplex method is. It can literally solve any linear program you can come up with as long as you standardize the linear program to a normal linear program and how it looks like. So computers use this simplex algorithm to solve linear programs so that you don't have to, but you can using the simplex method as you can use the simplex method to solve any linear program by hand. But computers just use this algorithm for you. They perform it a lot faster than you. And yeah. Okay, so now let's get into the actual ideology behind the simplex method. So here you have all of your constraints in the graph. There are non-negativity constraints as well, as shown by the fact that um, there's only data in the first quadrant. So we have our constraints and we have our feasible region right here because this is the structure that is created by the constraints. And the simplex method graphs the linear program. It finds the feasible region where all the constraints meet and form a little shape. And um, the simplex method also runs through the corners of this shape. And these corners are also known as basic feasible solutions, which are also extreme points. And these basic feasible solutions um, are basically just the edges of the feasible boundary. So the simplex method runs through all of these corners. In this example, there are only four, but usually there are many more and in other dimensions too. So it runs through these corners and it tries to optimize the objective function by finding the best feasible solution that maximizes or minimizes the objective function based on what you want. So let's talk about what extreme points are because, as I just mentioned, the basic feasible solutions, which are the corners, are extreme points, and it's important to ensure that the solutions are extreme points. Okay, so extreme points are points on a shape where any straight line can be drawn through it and it is not fully within the shape. What does that mean? So, we have our shape, right? Here we have a triangle. The extreme point would be the corners because there's no line that you can draw through it that is within the triangle. So this blue point over here, there is a line where you can draw through this dot where it is in the triangle, which means that it's not extreme. For example, that line would be just this line because it's right on the boundary of the triangle, and if it's on the boundary of the triangle, it's technically still within the triangle. And then for this point, you can draw this line. 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 And for these 2 points, you can draw infinitely many lines. And then there's this shape over here. So these are all not extreme points because you can draw many lines through them. And then over here, this is also a not extreme point because you can draw this line through it. But one thing to keep in mind is that this over here is an all of these points on this curve right here are extreme because there is no way for you to draw a line that covers all the points because this is circular, it's not straight. And because it's curved, there's no way for a line to go through one point on this curve and another point on the curve. There can only be a tangent line. So that's why all the points on this curve are extreme. Now over here, this is an extreme point, these four right here. This is not an extreme point, even though it is a corner, because the reason why it's not an extreme point is because you can draw a line right through here or right through there, and that's technically still within the shape. And yeah, So the blue ones, remember, there's a key right here. The blue ones are not extreme and the red ones are extreme. Okay, so that's it for the simplex method. Keep in mind that the simplex method algorithm runs through all of the corners or the basic feasible solutions of the graph that it maps out in the feasible region. And it finds these corners and it finds the best optimal solution within these corners. Okay, that's the idea behind the simplex method. Goodbye. Thank you for watching.